Hello everyone, welcome to the day 6 of the C Programming Bootcamp. So before I start, let me remind you that there will be a Google form which will be posted in the live chat at the end of the session. Please don't forget to fill the form for attendance. And today we are going to learn two things. The two things are structures and files. Right. So we have learned about arrays previously on the day 4 or the day 4. So when we have learned about the arrays, what is the two or three things that I've asked you to remember? They should be of the homogeneous data type, right? And it will be stored at the contiguous memory location. Right. So these 2 points you remembered about the arrays, right? So when you have remembered about the arrays like this, so they thought of what if we want to store data of the different data types, like for example, you have a roll number sheet. Yeah, right. So in the roll number sheet is nothing but an Excel sheet which consists of your roll number and an admission number if that is present, and also your name. So whenever you want to check your roll number, you're gonna go to that sheet and you're going to check it. Now what will be present in that sheet? As I said to you, the three columns. Now when you see those three columns, the roll number is an integer, right? And your admission number is an integer, and your name is a character. So three out of three different data types. So in previous time, when this Windows operating system, Microsoft, these things weren't there at all. Now how were they able to store different data types in the same thing, in the same file, and in the same file, and with the same name? So they thought of something known as structures over here, right? So the structures we are able to store with one particular name, we are able to store with more than one data type. Right. So the data type consists of, as we thought, the roll number, admission number, and name. So roll number, admission number, and name is two integers and one character type, character array, right? Character array, which is nothing but a string, right? So anyway, let me start. Structures. So it is a user-defined data type. So it is a data type, user-defined data type, that has members of heterogeneous data types. So as I said, you heterogeneous over there with the arrays, it is homogeneous. Here it is heterogeneous data types. So this is how you're gonna write the syntax. Right, structure name. See, in any whatever you're trying to do with where whatever you're trying to initialize a variable or a constant, the thing that we commonly do is that we usually write the data type. In any case, you write int I, you write character j, something like that. You obviously define the data type over there. Now what is the data type? The data type is structure. So instead of the structure, the whole word, we have taken a short form as usual. So the short form is that struct, struct. So we are going to write struct and the structure name. So this is the same for almost all the data types that we have used. Even if it is an array, we are just going to use that particular square brackets, right? So accordingly, array is not a data type, but I'm just saying how to initialize the things, right? So anyway, structure name, and then we are going to write it like this, right? The curly braces, the data type member1, data type member2. Now data type is nothing but int. Now the member1 means the column name 1 that we thought of. The column name might be the roll number, and then the so if it is roll number, it is integer. So integer roll number, and then the let me take name, right? So character, and then this is the member 2, so that is marks, right? So you have understood that, and you most need to remember about this semicolon after the curly braces. Many people will forget about this and they will lose marks. See here, after every line, as usual, you're gonna write a semicolon, but even after the curly braces, you need to write a semicolon for structures, right? This is the most important point, right? So the structure definition and initialization. So this is an example of the structure initialization. As I said you before, this is this data type and member1, structure, struct of struct name, and this is how we are gonna write. See, struct of books means we are defining a structure known as books. The name is books, and then the curly braces, as you have understood. So character title of 50 means 50 space. As it is a character, we are defining the number, right? an array, I mean an array which has a 50 spaces, and another author which has an array which has a 50 spaces, 50 elements, and again integer of book ID, right? That is also fine. Now you need to remember a part that whenever you are initializing the names for something, and even in the when you're defining the names for the files, you never should give a space between them when you're a coder. When you're a coder and when you're writing code, the reason behind is that it will not be considered, I mean, when you're using a Linux operating system, it will not be considered as one particular file. You will get an error. So whenever you want to use a particular space over there, we usually give it with an underscore. This is the most important point. When you're gonna use a Linux operating system or Unix operating system, when you give space over there, it will be a problem. And in most cases, in most cases, not most importantly, you should also give smaller names to avoid errors. Now, if you give bigger names and there is a error with some spellings over there or something like that, or if you give spaces between them, there will be a problem. So instead of writing book identification number here, he just wrote book ID. So you need to short the names, and you also, instead of giving space, you need to give the underscore. That is the use of the underscore, right? And here you're gonna write book, right? Now access the data available in the structure variable. Right. Now we have learned about the pointers yesterday. Now what have you learned about the pointers? You understood that we are saving the memory number of that particular, for example, let me take pointer P and A. Right. A is having a value of 15 that is being stored in a particular memory. That particular memory number is being stored in the pointer. That is another block of the memory. In that particular other block of the memory, the value of the memory value of the A is being stored. So whenever you want to whenever you want to do the calculations, you are going to use that particular pointer number to access the data. That is the advantage that we have thought about. So we have understood about the pointer. Now as we are going to learn files also, there is something known as a file pointer that we are going to learn in a near future. So anyway, we are going to access the things using in the structures also. We are going to use with the pointers, right? Now if you are using pointers, then you are going to use arrow. Now the arrow that I have used on the day 1 or the day 2 in the printf statement is different from this arrow operator. Now the dot and the arrow operators are different, and I'm 90% sure that is in there in the previous on the day 1 PPT. So anyway, this is the dot operator. If you want to access the normal variable, then you use the dot operator. And else if it is arrow, if you are going to use arrow is nothing but the hyphen and the greater than symbol. So that is nothing but the arrow operator. So anyway, I'm going to show it to you in the code. So the nested structure, nested structure is a structure inside a structure. So you need to understand a very small word over here. Nested means one inside the other, right? One inside the other. You have seen the nested loops, and you have also seen the nested condition statements, right? Nested if else if, and those all things. So and function inside the function and all those means nested means one inside the other. So whenever you are going to use nested, you need to understand one is inside the other. So nested structure, right? A structure inside a structure. So this is how we are going to write the nested structure. Struct of student, int roll number, char number, struct address. Now why have I used another thing? So why have I used another thing? As I said to you, now there can be take an example of an Excel sheet over here, right? In an Excel sheet, what will happen? We might have a sub column. Each column might have a sub column, right? So for that particular sub column, we are going to use this structure inside a structure, right? It is very easy to use struct of address. So as you know, as you have understood the syntax by now, see, even after this particular curly braces also, we need to write a semicolon, and the whole thing after this particular curly braces also, we need to write a semicolon. Now that's fine. Now let's go to the next slide. So then the next program that you're going to learn is the self-referential structure. So anyway, let me instead of asking you to understand this, I'm just going to do the program, right? So this is a basic example of a structure. So this is the documentation part, this is the pre-processing statements or the header files, right? And this is the structure definition. So you need to understand that the structure definition is being written in the similar way as we wrote it for functions. So what did we do it in the functions? We didn't write it in the main block. We wrote it outside of the main block. And in the functions part, how did we say to the main block that a structure part should be executed? We called the function over there. So here also we are going to call the function and see how we are going to do it, right? So this is the struct as that I said you it. This is the data type, right? This is the data type. Now we have defined the name. The name of this data type is nothing but the student. So let's assume there is only one particular class which consists of the different students. So as I said you, there are the different data types. This is the data type, and the member one is nothing but the column name, right? And again char, this is the column name, right? And the float CGPA. Because CGPA, why have I used float? You might have a doubt. Float is nothing but it consists of decimal numbers, right? As I said you on the day one itself, right? So about the data types, I said you. So the float consists of data types. I can also use double, but I don't need that many decimals after the dot, right? At least I guess only there are two decimals, right? So float is sufficient. So anyway, after the curly braces, as I said you before, there should be a semicolon. So once you have understood this part, now coming to the main part, right? So you need to understand in any C program or in any other coding coding language that you're going to learn, the main file, the main block is the first one that is going to be executed. So whenever you're going to execute the main block, there should be some reference that you're using the function or the structure over here. And you might also learn something about the union, right? Even about the union, you are going to write something in the main block, right? So anyway, union is also very similar to the structure data type. So anyway, I'm just going to say about the structure and not the union, because it is a little complex anyway. So structure student 1 and S1. So what am I doing here? I use the word struct and student. And what I'm doing here, I'm passing a structure variable S1, right? I'm giving an S1 means I'm defining a new thing, right? I'm defining a new thing. S1 means the student number 1. For suppose I wrote it like that, right? And structure variable with initialization. That is what I've done here, right? So I'm giving a new names S1, right? So whatever I'm going see now, there might be 60 students in your class. Now there might be 30 students in your class. So there might be 15 students in your class. So for every person, for every student, we need to have a particular row, right? So you know how a Excel sheet looks like. So for every student, there will be a particular row where he can access his particular details. So in the same way, there might be 60 students. So for each and every student, the values, as I've written here, the hall ticket number, their gender, and their CGPA is different from the others, right? Okay, is different from the others. And so what I'm trying to tell you is that for each row, we should add a particular value. So here I'm giving the student number 1, right? So here I'm defining a main student number 1, right? So what am I doing? Instead of me giving the values over here, I'm just going to type the values. I want the user to type the values. So where is it going to be used for this particular program? Where am I going to use this part? Now let's think. Now there is a particular class teacher. She knows how to code C language. So what she is going to take, after one student after the other, she'll sit in the class and she'll ask to uh, come one after the other and she'll note the values by typing. So this is what she is going to do. She is going to define for 60 students or 30 students or the 15 students. So whenever she's going to do that, she is going to enter the values for each and every student, their hall ticket number, their CGPA, and their gender, right? So we have understood that part. So that I'm going to define one for the pointers over here. So what I've done for the pointers I'm defining. So when I'm defining for the pointers, just as an array that we have done before, we are going to write it like this: s2 ampersand s1, means s2 will store the address of the s1. Right. So as it is pointer, it will point to the address of the variable, address of the array, address of the structure, so on. So here you need to understand the next part that I forgot over here. You know about this part, right? If it is a double, if it is an integer, we are going to use percentage d. If it is float, we are going to use percentage f. And if it is a character array, we are going to use percentage c. So accordingly, so whatever value that the user wants to enter, see, first hall ticket number should be entered. So when then the person writes the hall ticket number, that should be saved. So the hall ticket number is being saved. So the ampersand s1 dot ht number. So as you know, in this kind of statement, we write it with the ampersand because in that particular address, that number, that data type should be stored, or the thing should be stored, like the hall ticket number or the CGP or the gender. So accordingly, the hall ticket number should be stored. Hall ticket number is an integer. So accordingly, whatever variables that we have defined in that particular order only, we should write the commas and the variables or the constants over here, right? So first, the percentage d means it is going to scan for the hall ticket number, and then the percentage f, which is going to scan for s1.cgpa, and then the gender, right? And the gender percentage c means the character that will be stored, right? So we have used the dot operator over here. So why do we use the dot operator? If you want to do it with the same values, then you are going to use dot operator. We have understood that part. Now coming to the pointer part. Struct student of pointer, pointer star or asterisk residue, and then the s2, right? S2 equal to ampersand s1. I said about this part already. So coming to accessing of the member, now I want to print the values also, right? I also want to print the values, so I'm going to use this part using pointers. Now I can just use without using pointers also I can print it, but I want to use pointers because I I want to do it with the pointers, right? So printf hall ticket number should be printed. Hall ticket number is s2 dot, which is pointing, right? So what does this arrow do? It is pointing to hall ticket number. Now S2 is pointing to the hall ticket number. Now as I said here, it will pointing to the address. So if it will be pointing to the address, it will come here and it will check somewhere the value of the hall ticket number is being stored, right? So that particular hall ticket number will be stored and that particular number will be saved, right? And again the gender, now that particular array, character, and again cgpa, right, the number. So that is how we are going to print. Now you can change the order. You do see here, first I've taken the hall ticket number and then the cgpa and then the gender. So what here I'm printing accordingly what I want: the first hall ticket number, then the gender, then the cgpa, right? So return 0. I'm just going to compile and run the file. So I've just given an example over here. His roll number, his hall ticket number is 101. His what do you call it? The MN 8.3. So hall ticket number, right? So I'm just going to write the same values. And then so here you need to understand that I have made a mistake over here. See, the first CGPA is being taken, right? So the first, when it is going to take the CGPA, I wrote it in a different manner. So when I'm going to write it in a different manner, it is just going to see 101 is being taken. So anyway, the gender and the CGPA will not be considered because they are in the different order. Whatever order I asked you to write it in the program, in the same order you need to write a program. Now we shouldn't understand that in whatever order we write it is going to take it. No. Whatever we wrote, however we are asked to scan it, that is how it is going to scan. So I'm going to compile and run it again. Right. enter hall ticket number 101, and then M, and then 8.3. Right. And here we also need to take care that whenever we are writing for it, again I done the same mistake. So I'm going to compile and run it again. 101, 8.3, and capital M. See, it has been taken. Hall ticket number 101, gender M, CGPA. Whatever order I want to print, I can print. So this is the basic example of how we can use a structure file of different data types, and this is how you're going to write the syntax. All these are clear over here. So now let's go to the size of the structure. Right. So here I did not take the character, I did not consider the name also. Here I have used the name. Right. Whenever the size is structure variable, that is the documentation part. This is the pre-processing statements and the header files. So the struct student int ht number char name. So character arrays the string. So double. Right. I'm using double over here. Whatever I want to use, I can use it. So as I said I use double. So the semicolon after the curly braces, understood. The structure int main structure struct student s1, and then I'm gonna print the values s1.ht number, size of s1.ht number, and s1.name and s1.cgpa. So anyway, this is why is this bold? You might have the doubt. So as I said before, only uh, the keywords that I've said before are going to be bold. And why is this bold? Because this is also keyword, and this is a method. Okay, what is a method? What is a keyword? Keyword 32 keywords are shown on the day one itself. Right. So in the keywords you can check the size of. So whatever we can find the size of an array, we can find the size of a structure, and so on. So in the same way as I wrote it for the syntax, I wrote it in the print statement also. So anyway, the size of the structure is ht number, which is going to be 4, right? The integer is always 4, and the char is of 13 elements, so it is going to print 13 elements. And the CGPA is of double, right? It is going to have 8 values. And you need to understand over here that I wrote the values over here because that is what I'm expecting. So let's see whether we got it or not. And the size of the structure means the size of the whole this data type structure student that I've defined over here is going to have a memory of sum of all these data types. Now that is very obvious, right? Sum of all these data types, sum of the size of each data things is that 4 plus 13 plus 8. Right, that is nothing but 25. So I am going to compile and run it. See, size of HT number is 4, 13 and 8. Right. Why am I having 32 over here? Because there is so actually what we are expecting the sum of all these 4 plus 13 plus 8. So why am I getting 32 over here? So there is a change of another 7. So why did we miss that 7? So here we need to understand that there is a extra of 7. So why is there an extra of 7? This is an important question, and many of them will ask, because if you haven't tried this program you will not know about this. So why is there an extra thing? Something known as packing, right? Packing is nothing but it again depends on the processor. From system to system it will change as the size of the data type change. So accordingly for my particular system it is 7. So it might be different for your program, and I asked you to try it. So how will this change is something, I mean, will it be sum of the things? No. That is what you need to remember. It will be different from the sum of the things. So let me go to the next part. Right. So PPT self-referential structure. So the self-referential structure is a structure that has a member pointing to some data type. Okay, so in data1 char data2, that's fine. Struct node of link. Again, this link is pointing towards the same thing. So that is nothing but the self-referential structure. So I'm just going to show you the program of the self-referential structure. Yeah, here it is. So this is the documentation part, pre-processing statements, that's fine. Now the four things: hall ticket number, CGPA, name, and the next. Okay, here the next is pointing towards the student again. See, again this pointing to the student, right? So here it is, int main struct student. So I'm passing four values over here, struct student s1, and these are the four values. So when I'm going to take the four values, then I'm again taking a pointer over here, right? So when I'm taking a pointer over here, I'm just going to s1 dot next. Means what is going on over here? We need to understand that. Okay, we need to understand that s1, right? S1 is pointing to S2, right? See, that is what I'm trying to save here. Okay, S1 is pointing to S2, S2 is pointing to S3, means that is saving the address also. I mean, in this particular part, right? So in the array part, okay. So S4 dot next is pointing to null, means it is right. So and p equal to ampersand S1, you have understood this part from by now. So while p is not equal to null, means it should come here till S3, it should come and it should print the values, means the values are these values, right? So 101, 9.3, these CGPA and roll number and the place, right? So those values should be printed, right? So I've actually taken four values: CBIT, MGIT, IT, and Hyderabad. So those values will be printed, right? So here I have used this operator, right? As it should point to the next. What is next? Next is over here, which I started over here, which is again pointing to hall ticket number. So what is the use of this self-referential structure? The idea of this self-referential structure is that it can start from the beginning again, right? We have understood this part. While p is not equal to null, by now you have understood. But the ones who did not understand, you need to understand that the p is not equal to null as a condition, means it should come till null and it should stop, right? So that is what the condition over here that I have written, right? Once you have understood that part, now let me go to the next part. The next part is that, so this is the structure function. So seeing it, you will understand this part. So void display. So this is a structure you have understood by now. And once you have understood this part, this is what you're going to do. This is about the void display structure. This is nothing but a function. Very good. Now struct function, which is actually having its argument as structure student A. Now you have understood this part. Now this is a function. So this is a function call over here, right? This is the function call. Now let us see what we are going to write it in the function part. So in the function part, I'm going to take the printf, right? Structure student A. For particular student A, I'm giving this. So a dot name means, for example, in the example that I showed you, I've shown you x comma y for those particular particles, and I've said return x plus y over there, means I've defined to for particular argument. Here also what I'm trying to do for a particular student A, how it should matter, how the function should be defined. So for that particular student, I have written like this: a dot name, a dot roll number, those should be printed, right? And what should be printed? Their marks should be printed, right? Again, I have used the dot operator. You should understand over here because it is a structure, right? Printf marks in the deep subject, means now what I'm going to do, I have printed an iteration statement from 0 to 5, right? In the 0 to 5, that has been printed. Now again, both are numbers, right? The first number is going to be the 0th subject, right? So the 0th subject I value will be printed, and then %d. Now a dot marks will be printed. So that is what I'm trying to tell here. Both will be printed, and for which values? These values, right? So for this particular student, I'm defining, right? I'm defining his college, right? I'm Okay, so I have taken an example of CBIT. So the gender and his subjects in the five subjects. So instead of taking zero the subject, let me take it as one subject, and it should be I less than or equal to 5. So this is something meaningful. So anyway, I'm going to compile and run it. So what I'm trying to do here for a particular student S1, right? I have given the values in the program itself. I want to display them. So there are different data types, so I'm going to do them, right? So right, this is it. So the marks are 98. Okay, let me run the right. So 98, 68, 87, 93, and 101. So this is how we are going to get the files, right? So once you have understood this part, this is the dynamic memory allocation part. So you have understood the malloc and the calloc, how we are going to write. I shown you yesterday. So there are four, right? Float PER, as I said you, to make it short forms. Instead of writing percentage, I just wrote it as PER. Okay, now this is a float, as there can be two decimals part, and integer. Now I'm not going to write this malloc part. So structure student, size of structure student, as I said you, this is a method size of. So malloc, right? So the data type that I'm defining it here is strut. So using the arrow operator, so I've written this part, and then now again I'm going to free the memory. So you might have understood what the statement is doing. So with using the structures and the pointers and the operators have used this program, and the dynamic memory allocation. So I wrote it as dynamic memory structure ASC, and I'm going to compile and run it. So these are two warnings over here. So anyway, the value has been printed. See this, I have done it for only one particular student. You can try it for many students, right? So I have given the values over here 101, M, and 8.5. Those values have been printed. So how I have done that? Structures, files, and again dynamic memory allocation. So you can write hundreds of programs like this. So once you have understood this part, now let's go to the files part. Right. So in previous time, as I said you, many use the Linux operating system, the operating system which existed in the 1970s, and with the whole program, the whole operating system works on coding. There would be no mouse at all. So when there was no mouse, you're gonna do for opening the file also you need to write a particular code. So how do we need to write the code and everything? That should be done in the C language itself. So for now here also using the Windows operating system and the compiler that we have using, we can handle the file. So what file are we going to use? A text file we are going to use, right? So file handling in C. A file may be anything from the disk file to a terminal or a printer, right? It can be even as you can take an Excel sheet is also a file, and you can also take a PPT is also a file, a Word document is also a file, a text file is also a file. You can take any file, right? So a file is associated with a stream by performing an open operation, and it is dissociated from stream by close operation. Means stream is nothing but something which is flowing. So we are going to handle that file using our code. Right. Now, how is it going to be opened? That is going to be opened using this open operation, right? Now those methods I'll show it to you, and that can be closed by close operation. That is fine. Now all files are automatically closed when the program using them terminates, normally by main. Okay, now obviously we are going to write a program over here, not as we write in this Linux operating system. We are going to write it in a compiler itself. Now we are going to open it by fopen, and we are going to close it by fclose. That is fine. Now it is not And the most important part is that we need to remember we need to close the file, right? We need to close the file, that is fine. And all the files are automatically closed on the program, using them normally by main returning to the operating system or by call to exit. That is fine. Files are not closed when a program crashes, right? So opening a file is nothing but, right, if you want to open a particular file, you'll click on the file in the Windows operating system. So what in the Linux operating system we do, if you want to open a file, we write vi and the file name and the extension. It is C program, Java program, Python program. If it is C, we write it as .c. If it is Java, we write it as .java. If it is Python, we write it as .py. So anyway, these were all in the file handling system. So there are two types of files, the text file and the binary file. Now as I said you, the binary file consists of zeros, ones and zeros. So if it consists of the ones and zeros, we need to understand that we cannot correct the binary file. So what we need? We need text file. So text file is nothing but the letters, words, or what the characters that we have written in the file, right? So we know how to use that part. So that is text file. So the binary file we cannot handle ones and zeros, which will be only understood by our computer, our machine. So the text file, it is a sequence of characters. It can be organized into lines terminated by a new line character. Right. Binary file, it is a sequence of bytes with one-to-one correspondence to those in the external device. That is, there are no character translations. Right. So these are the methods to open a file, to close a file, to get the contents of the file and everything. So here we need to also understand that we can copy the contents of the file using the code. We can see the contents of the file from the code. We can write the contents of the file from the code. We can append the files to the contents from the code. Okay, now I have used three words that you might not understand. I'm going to define each and every word. The first word is reading a character from the file. Now what is reading the character? For example, if you have downloaded a file from your mail or a file from your WhatsApp web. So as soon as you open that, after you download it and you open that file in the Microsoft operating system itself, you will not be able to edit. Right? You need to press on the option enable editing. So what is the difference over there? Why should we press on enable editing? Because the file is being opened in read mode. When it is going to be opened in read mode, we are not allowed to make any changes, right? So if we want to make some changes, right, then we need to open in the write mode. Okay, what is write mode? If you want to add contents in a file, we need to add write mode. Now there is an append mode, right? What is append mode? Append mode is nothing but the contents of the file should already be present and we want to add some contents to the file. For example, the word ed of our edspread channel is already being present. Okay, spread is not there. So when the spread is not there, we want to add that particular spread word. So the file should be first read and we should also able to add the content, means write should also be present. So the methods are again read and write, both operations should be done, right? So both operations should be done. That can be done in the append mode. Appending is nothing but adding, right? What is adding? Adding means adding a new part, right? You have understood that part. So how the next part is how are we going to access the files each and every character by character or number by number in a file. So then we are going to use the file pointer, right? File pointer. So what is a file pointer? It will point to each and every character. So you can think that a file pointer is nothing but an arrow which points to every character, and a file pointer is also, it is going to point the file, right? So once you have understood this all parts, now we can come into the methods that are there on this particular slide. So file close, we can close the file like this. Get C reads a character from a file. So you can use each one of these methods f printf f scanf, right, writes the data, right, printf scanf get w reads an integer from the file, put w writes an integer to a file, f seek sets a position to a desired point in the file. Now if I don't want to, now this, for this particular thing, if I don't want to read the file from the first point, I want to read the file from the 20th line or from the 20th character of the file, so we can use fseek, ftell and rewind methods, right? So feof. So when a file is open for the binary input, an integer value to the end of file may be read, right? So how will our program know that the file has been entered? So the idea behind that is, we are going to use, if the pointer is pointing to null, then it has reached to the end point, right? So that is nothing but the end of the file part. Now this is the many people ask this question about the what is the end of the file. So what is feof? So that is feof, if it has reached the last point of the file, there are no more characters, it is pointing to null, it means it has reached the end of the file, and then we should close the file, right? So the input routine will indicate eof in such case, even though the end of file has not reached. So even in if you want to end the, I mean, if I don't want to write the whole edspread, I just want to first two letters, even after ed also I can write the end of the file, means it should be closed, even that part can be done, right? So I am going to show you two programs over here. So here it is, files, programs. So I'm going to show you two programs. So this is how a notepad looks, right? You might have tried using this notepad. You might have started using this notepad for writing some HTML code or web development codes if you have ever started. So this is how a notepad looks, and if you want to know how you can start a notepad, just go to right click and go to new, and then you can find the notepad or the text document, right? In the text document is nothing but the notepad, you can start using them. So there is a file, sample file, I have named it sample. So the file read.c, right, standard library.h, this I have added. So this is a file fp, that is nothing but a file pointer. So this is why we are using the pointer over here. So character, file name, and you know about this part, this is a character array, and then I'm taking the input of the file name from the user itself, right? So this part you have understood. So that should be saved in the file name, right? So file should be opened according to what I've written. So file should be open. Now I said you about the three modes, right? The three modes: read mode, write mode, and the append mode. So accordingly, if it is read, we are going to write R. If it is write, we are going to write W, and if it's append, we are going to write A. So accordingly, we are going to write the file name, right? The file name is something what I have written over here. So the same file name I am writing it here, and in the read mode I want to write in the read mode. So if the file pointer is pointing to null, means double equal to, you have understood by now. If it is pointing to null, we are going to say printf cannot open file. So how am I going to read the contents of the file? So I've written a loop, right? So as I said you, the pointer will be pointing to each character. So that should be done one after the other. So if it should be done one after the other, and it should continue the same process again and again, we are going to write it in a statement. So the statement is that printf, right, while ch is not equal to end of the file, for end of the file we are going to write it as eof. You have understood that part as shown you in the PPT. So printf %ch, so ch will be printed, means the character which is pointing, I mean the character which is being pointed will be printed over here, and that will be continued. Character is equal to fgetc fp. Fgetc is nothing but a method, right? You have understood this part. Now the file should be closed, as I said before. File should be closed means file pointer should be closed. Now how many times will this particular loop continue? Till we reach the end of the file. Once we reach the end of the file should be closed. Right, we have understood that part. Then the return 0. So I'm going to compile and run it. Now whatever the contents we have in that sample.txt. So when we are writing this particular thing, we need to also give the extension of the file. So for every file there will be an extension, sample.txt. See, the contents of the file have been printed. You can check each and every part of the file again. Right. So the next part I'm going to do is that file copy. Right, file copy. Now this is the sample one. I'm just going to delete this whole part and save it. Right, now what I'm going to do is that I want to save the contents of the sample file again in the sample one. So this is what I'm going to do. I have written a program. Right, so this is the program file copy.c. So I have two file pointers. So the file pointers, if I am opening two files one after the other, fp1 and fp2 file open, and I have written I'm not taking the input from the user. So sample.txt, sample1.txt. Now this should be in the read mode itself. I don't need to write this in the write mode. Now the second part should be in the write mode. You have understood this part. Now this is a method fputc. You need to remember this. So in the fputc, what am I going to put? Ch. Now the file pointer 2, right? So we're going to write this as file pointer 2. So what is the loop over here? Till it reaches the end of the file, the value should be keeping it in fp2. So I'm closing the two files and done. Right, you have understood this part. I'm saving it, compile and run. Right, so it has been done. We are not printf anything. So let us see whether the file content has been saved or not. So in the sample one, as I've shown you before, there is nothing over there. So anyway, I'm going to show you. See, the content of the file has been changed. So if you want to do it again, you can do it again. See, I've done this, right? So I've deleted everything. See, I'm opening it. There is no content over here. So file copy, compile and run. See, it has been done. We are not printing anything. So sample one. See, the file content has been copied over here. So yeah, I guess you have understood everything till now. So the current file position pointer, this I've already said you. In order to keep track of the position where input and operations take place, a pointer is maintained in the file structure. The current location of the and the ftell option, now I've said you in the methods itself, the active pointer can be found with the help of the ftell function. Right. You can also use this setting current file pointer position. Now seek set, seek current, seek end. Now seek set is going beginning of the file. Now seek current is current file position of the pointer, and the seek end is end of the file. So according to the number, we can understand. So instead of using seek set, seek cur or seek end, we can use that. So once we have understood this part, we have completed two topics today: the structures and the files topic. So thank you guys, thank you for listening. And so before I end, let me remind you that there will be a Google form which will be posted in the live chat by now. So please don't forget to fill the form for attendance.